Hi, I am Dr. Prashant Kumar Bolton, Professor, Mechanical Engineering Department, GIS College of Engineering, Kolani. My subject topic is Advanced Welding Technology, ME 703A. Today is my fourth lecture, arc welding and shielded metal arc welding, SMAW. Arc welding. Arc welding is a type of welding process using an electric arc to create heat to melt and join metals by applying power supply creates an electric arc between a consumable or non-consumable electrode and the base metal using either direct or alternative current. This is a schematic diagram, basic welding circuit. That is one cable is a work cable, another cable is a that is electrode cable. The left side is a AC or DC machine power supply and control, and the electrode is in the electrode holder. This is the electrode, and arc is formed. So melting is done. How an arc is formed? The arc is like a flame of intense heat that is generated as the electric current passes through a highly resistance air gap. Electric arc welding. This is the power supply, AC and DC. There is welding lead, electrode, and the return cable. And this earthing is there, workpiece, and the arc is formed. An arc is generated between two conductors named cathode and anode, considering direct current DC. When it is separated by air between the electrode, it is ionized by the potential difference and reducing the electrical resistance of the air column. An arc is a sustained electric discharge through this ionized gas column called plasma between the two electrodes. The arc produces a temperature of about 6,500 degrees Fahrenheit, and that is equivalent to 3,600 degrees centigrade at the tip. This heat melts both the base metal and the electrode, producing a pool of molten metal, sometimes called a cathode. The cathode solidifies behind the electrode as it is moved along the joint. The result is a friction bond. Arc welding. The arc can be either manually or mechanically guided along the line of the joint by the electrode either simply carries the current or conducts the current and melt into the weld pool at the same time to supply filler metal to the joint. Because the metal reacts chemically to oxygen and nitrogen in the air when heated to high temperatures by the arc, the protective shielding gas or flux-coated electrode is used to minimize the contact of the molten metal with the air. Once cooled, the molten metal solidifies to form a metallurgical bond. Arc welding. Many things around us are welded by arc welding, that is pipelines that bring fresh water, towers that carry electricity to houses, cars and buses that takes people where they need to go. Arc welding continues to be used extensively in the construction of steel structure and in industrial fabrication. The process is used primarily to weld iron and steel, including stainless steel, but aluminum, nickel, copper alloys can also be welded with this method. It dominates other welding processes in the maintenance and repair industry, and through flux core arc welding is Though flux welding is growing in popularity, it is popular because it can be used in the field without complicated equipment and gases. Principle of work. A suitable gap is kept between the work and an electrode. A high current is passed through the circuit. The electric energy is converted into heat energy, producing a temperature of 3000 degrees centigrade to 4000 degrees centigrade. This heat melts the edge to be welded and molten pool is formed. On solidification, the welding joints is obtained. Arc welding. Basic arc welding. Below the welding, before the welding, two parts are to be welded in view. Number two feature is during the welding, base metal are melted and filler metal are added to the molten pool. This is the filler metal and the molten pool, sealing gases, and behind the sealing gas, molten pool is there. Electrode and arc is formed. Picture 3 is completed weldment. Electric power for arc welding. Current used may be AC or DC. In AC, instead of 220 volt at 550 degree ampere, for example, the power supplied by the transformer is around 70 to 45 degree volt at currents up to 600 ampere. DC machines are made up to the capacity range of 600 amperes and 45 to 95 volts. DC can be divided into two ways, state polarity and reverse polarity. The polarity will affect the weld size and application. Welding polarity. In the state polarity, workpiece is added in plus sign and the electrode is a negative below, negative. Electrode holder negative. So arc is formed and in this state polarity, deep penetration, narrow weld is performed. And the heat, total heat, 1/3 heat in the electrode and 2/3 in the workpiece. So thicker plated are recommended for state polarity. Reverse polarity, workpiece is negative and the electrode is positive. In this case, heat is workpiece is 1/3 and electrode is 2/3. And shallow penetration and wide weld, wide range, shallow penetration. So in this case, reverse polarity, thinner polarity is preferred for welding. 5 most common arc welding processes. Sealed metal arc welding. The process name is known as SMAW or stick welding. Electrodes and rigid metal covered, flux covered, shielding, stick coating. Operator skill required, low. This diminishing, popularity is diminishing. Though in India, 65% total welding is done by the SMAW, manual electrodes. But in Europe and USA, 40% of welding is done by manual welding. Gas metal arc welding, GMAW, that is MIG welding, solid wire, CO2 gas sealing, and also sometimes argon is used. Operator skill required is low. Growing, fast growing, since it is automatic welding and productivity is higher, so it is growing. Flux core arc welding, FCAW or MIG welding, hollow wire, core materials, that is flux in the core materials. Operator skill required low. Growing. Gas tungsten arc welding, GTAW or T welding. Electrode is tungsten. gas, civilian gas is argon gas, and also sometimes helium gases is added. Operator skill require high, steady. Submerged arc welding, SAW welding, solid wear, agglomerated flux or fused flux is used. Operator skill require high, steady popularity, and of the total welding, 7 to 8% of the total welding is done by SAW. Manual metal arc welding, it is called sometimes it is called MMA welding, SMAW, or stick welding. Manual metal arc welding, MMA or MMAW is also known as sillet metal arc welding, flux sillet arc welding, or stick welding is a process where the arc is struck between an electrode flux, coated metal rod, and the workpiece. Both the rod and the surface of the workpiece melt to create a weld. The electrode used in this process is consumed, a rod covered with flux. The flux bonds to form into a protective layer or cover for the weld. The current types used in this process can either be AC or DC, depending on the design of the weld, which will be stated in the WPS. WPS is a welding procedure specification. Manual metal arc welding. Manual metal arc welding was first invented in Russia in 1888. The development of coated electrodes did not occur until the early 1900s when the Kjellberg process was invented in Sweden and the Processe arc method was invented in the UK. As the demand for sound weld grew, manual metal arc became synonymous with coated electrodes. When an arc is struck between the coated metal rod electrode, the workpiece, simultaneously melting of the flux coating on the rod will form gas and slag which protect the weld pool from the surrounding atmosphere. The slag will solidify and cool and must be chipped off the weld bit once the weld run is complete or before the next weld pass is deposited. The process allows only short length of welding to be produced before a new electrode is needed be inserted in the welding electrode holder. Weld penetration is low and the quality of the finished weld deposit is highly dependent on the skill of the welder. This is a welding action of a coated stick electrode. This left side top is electrodes adhered, and this is a electrode covered electrode, door wire and sealing coating. The electrode that is molten gaseous sealed is there, and the bottom is cathode, molten weld metal, that is penetration, and the slag is on the top surface, weld deposit, and the base metal. Type of flux and electrodes. To strike an arc between the electrode and base metal, such as carbon steel, and to produce a good quality weld, a stick welder must ensure their welding machines are fitted with the suitable electrodes. Arc stability, depth of penetration, metal deposition rate, and positional capability greatly influenced by the chemical composition of the flux coating or electrode. Electrodes can be divided into three main groups. One is cellulosic, butyl, and basic. Cellulosic electrodes contain a high proportion of cellulose in the coating and are characterized by a deeply penetrating arc and a rapid burn-off rate, giving high welding speeds. Features. deep penetration in all positions, suitability of vertical downhand welding, high level of hydrogen generated, risk of cracking in the heat affected zone as butyl electrodes contain high proportion of titanium dioxide, butyl in the coating. Titanium oxide promotes easy arc ignition, smooth and operational low spatter. They can be used with AC and DC power source in all positions. The electrodes are specially suitable for welding fitted joints, horizontal or vertical positions. Features: moderate weld metal mechanical properties such as tensile strength, positional welding possible with a fluid slab containing fluid, fluoride. Basic electrodes contain a high proportion of calcium carbonate, that is limestone, and calcium fluoride, feldspar, in the coating. This makes their slab coating more fluid than butyl coating. This is also fast fusing, which assists welding in the vertical and overhead positions. These electrodes are used for welding medium and heavy section fabrications, where higher weld quality, good mechanical properties, and resistance to cracking due to high resistance are required. Features: low hydrogen weld metal, require high welding current speed, poor bead profile, convex or coarse surface profile. Function of electrodes is flux coverin. Provides the gaseous shield to protect the molten metal from air. Cellulose type electrode providing gas mixture of H2, CO, H2O, and CO2. Limestone type electrode, calcium carbonate, low in hydrogen, and it is used for welding metals that are susceptible to hydrogen cracking, such as high strength steel. Shielded metal arc welding, or popularly known as SMAW welding, is also called manual metal arc welding, MMAW. Flux shielded arc welding, or informally as stick welding, is a manual arc welding method that is consumable electrode coated with a flux to put the weld. This is a figure. Electrodes and welding is performed. Protecting shield, gaseous shield, electrode core wire with shielded heavy coating with heavy cellulose coating, heavy coating, penetration, tatter, and molten metal. Below is a schematic diagram of the SMAW equipments. That is, left side is AC and DC power source and control. Workpiece is connected with a cable, and another cable is connected with the electrode holder, electrode, and arc. Manual metal arc welding equipment, AC or DC arc welding machine, electrode with electrode holder, arc link cam, welding blades, connectors, other accessories in SMAW, leather gloves, face shield, chipping hammer, wire brush, cover all, that is PPE, safety boots, shoes, nose masks in the absence of fume extractor, and soon. However, all above mentioned can simply be referred to as personal protective equipment, PPE. Arc welding, because of the versatility of the process and the simplicity of its equipment and operation, shielded metal arc welding is one of the world's most popular welding processes. Workpiece and also the electrodes forming a pool of liquid metal, weld pool that pulls to create a joint. Since the weld is set, the flux coating of the conductor disintegrates, giving off vapor that function a shielding gas and providing a layer of slab. Each of that shields the weld space from atmospheric contamination. Because of the flexibility of the process and simplicity of the equipment and operation, shielded metal arc welding is one of all the world's number one and preferred welding processes. SMAW continues to be used extensively within the construction of heavy steel structures and in industrial fabrications. The process is used primarily to weld iron and steels, including stainless steel. However, aluminum, nickel, and copper alloy can even be welded with this technique. SMAW are often dangerous, unhealthy, like other different welding processes, if correct precautions are not taken. The method uses an open electric discharge that presents a risk of burning, which are prevented by personal protective equipment within this of significant leather gloves and sleep jackets. In addition, the brightness of the weld space is known as arc eye, within which ultraviolet lights causes inflammation of the cornea and might burn the retinas of the eye. Helmets that are used by welders are designed with dark face plates are worn to prevent such exposure. To safeguard the welding space is often surrounded by fabricated PVC film that protects mere staff from exposure to the ultraviolet lights from electrical arc, popularly known as soft floor environment. Type of electrodes. Electrodes can be divided into three groups. Fast field electrodes. Fast field electrodes are designed to melt quickly so that welding speed can be maximized. Fast pitch electrodes. Fast pitch electrodes supply filler metal that solidifies quickly, making welding in a variety of positions possible by preventing the weld pool from shifting significantly before solidifying. And intermediate electrodes go by the name fill freeze or fast follow electrodes. Safety measures to be adhered to SMAW to prevent injury to personal. Extreme caution shows the exercise when using any type of welding. Equipments in equipments. Injury can result from fire explosions, electric shock, and harmful agents. Both the general and specific safety precautions listed below must be strictly observed by workers who weld or cut metals. Do not permit unauthorized persons to use welding or cutting equipment. Remove all inflammable materials such as cotton, oil, gasoline, etc. from the vicinity of the welding. Do not weld in a building with wooden floor unless the floor are protected from hot metal by means of fire resistance fabric, sand, or other fireproof material. Before welding and cutting, warm this in close proximity who are not protected to wear proper clothing or gloves. Do not leave hot rejected electrode stubs, steel scraps, or tools on the floor or around the welding equipment. Accidents and or fires may occur. Keep a suitable fire extinguisher nearby at all times. Ensure the fire extinguisher is in operable condition. Advantages. Lower equipment cost than GTAW, flux hole arc welding, and gas metal arc welding. No bottle, gas, hose pipe, flow meter, TIG rig, wire feeder needed. quick change from one material to another, deposition rate faster than TTAW material manual, easy to move from one location to another. Some special electrodes are made for cutting and gouging, require no outside gas, and can be used outdoors in light to medium wind. Simple welding implements, portable, inexpensive power source, relatively inexpensive equipment. Welders use standard domestic current. Process is fast and reliable. Short learning curve. Equipment can be used for multiple functions. Electrical arc is about 4000 degrees centigrade. Used for maintenance and repair and field construction. Disadvantages: low deposition rate compared to GMAW or flux core arc welding. Filler metal cost per weld can be greater due to low deposition efficiency that can vary greatly with stub length. When the electrode length is less than 35 mm, it requires the electrode changing, lower the overall efficiency production rate. Production factor is typically lower unless welding on various material due to rod changing and chipping slack. Need more hand-eye coordinations than GMAW or flux core arc welding. GMAW and flux core arc welding is a semi-automatic welding. So more production is there, high productivity. Slack must be removed as compared to GTAW or GMAW. During the welding process, welding material, the work environment. Excessive heat can cause fainting, heat stress, and exhaustion. Excessive cold can cause frostbite, hypothermia, and fatigue. Follow an appropriate workplace routine and ensure availability of water. Thank you.